Hello, my dear students, and the rest of the learners. Welcome to part 28 of a 95-part series of tutorials in object-oriented programming series in C++. In this presentation, we are going to continue looking at the implementation of objects and the classes, with our focus being on what we call the friend functions or methods. My name is MemJM, or you can simply call me Emily Swap. What is a friend class? We looked at friend classes before. Now, what is a friend function? How do we distinguish between a friend function and a friend class? In part 27 of this series, we looked at what we call the friend classes. If you have not gone through that presentation, I would advise that to listen to part 27 of this series, and then you can come and proceed with the part 28 of this series so that you can be able to get a clear understanding of what we call the friend functions and the relationship between friend functions and friend classes, if there is any. A class can have global non-member functions and the member functions of other classes as friends. Such functions can directly access the private data members of objects of the class. In other words, we are saying that if you have made a function to become a friend of a certain class, then that function can be able to access the data members of the class in which the function has become a friend. They can also access protected members of that class. In other words, we are saying that if you make a function to become a friend of another class, then that friend method or friend function or friend member is able to access the data held by the members of the class in which it is a friend. Normally, you can only access the private members of a class through member functions of that class. And you can only access the protected data members of a class through member functions of a class derived from that class. That is normally, on the normal sense, in object-oriented programming. Just as I said before, in classes or in object-oriented programming, if you want a function to be able to manipulate the data members of a class, then that function should be made a member of the class in which it will be able to access the data members. However, we are saying that with the aspect of introduction of friend functions, then we are saying that even a function for another class can be able to access the data members, the private members or the protected data members of another class, as long as that function has been made a member, a friend member in that function or in that class. So, how is that possible? We declare a function as a friend in a class in which we want that function to manipulate its members. So friend declarations are not affected by access specifiers. And thus, you don't need and should not use the scope resolution operator when defining a friend function. Remember, if you don't define a function within the class in which it is a member, if you have to do the definition outside of that class, we said before that what you're supposed to do is to make use of what we call the scope resolution operator for the purposes of informing the compiler that this function that is being defined outside of a class belongs to class A, class B, etc. So the scope resolution operator is used when you are defining a function which is a member of a class outside of that class. And therefore, as we saw in the previous presentations of this series, is that what you are expected to do is to prototype that function as a member inside the class in which it belongs. And then you can do the definition outside of that class. But if you have a friend function, if you have a function, if you have a function, if you have a function outside of a class, even if that function is not a member of another class, if you have a function, if you have a function defined outside of a class, or in other words, if you have called any other function and that function is not a member of a given class, if you want that function to have access rights to the members of another class, then you are supposed to make that function a friend in that class or a friend for that class. And once you have made it a friend, remember, you are just making it a friend of a class. That function is not a member of the class. It's just a friend of that class. So in that case, you don't use the scope resolution operator. Why? Because the function that is a friend is not a member of the class, but a friend. So you don't use any scope resolution operator. Why? Because this function can even be used by any other class. So you can have a function, a simple function, being a friend of several classes, being a friend of several classes. And what we just need to do is to define or to include, let me use the best word here, is to include or declare, is to declare the friend class or the friend function, not the class, the friend function within the class in which you want this function to access its members. And once you do that, outside of that class, you don't need to use any scope resolution operator. So a friend non-member function is a non-member function that has special rights to access private data members of any object of the class when it is a friend. Remember, if a function has become a friend to a class, then it simply means that this function can, or when this function is invoked, it is able to access the private data members of the class in which it is a friend. And therefore, it also means that the object that is manipulating the class in which it is a friend can be passed to it as a parameter. So a friend function is prototyped within the definition of the class of which it is intended to be a friend, in the same way that we prototyped a friend class inside the class in which the other class was intended to be a friend. The prototype is prefixed with the keyword friend. So in the same way, we use the keyword friend for classes into presentation or tutorial part 27 of the series. That's the same way we use the same word friend when you're dealing with friend functions. Since a friend function is a non-member function, it is defined without using the scope resolution operator. Moreover, it is not called with respect to an object. There are situations where a function that means to access the private data members of the objects of a class cannot be called with respect to an object of the class. And therefore, in such situations, the function must be declared as a friend. Usually, a friend function takes one extra parameter as compared to a member function that performs the same task. This is because it cannot be called with respect to any object. Instead, the object itself appears as an explicit parameter in the function call. The following is therefore an example of a program implementing a friend non-member function called results. This is because it is prototyped in the class performance as a friend to the class, but its definition is outside of the class and it is not preceded by a scope resolution operator for that class. So this means that the function called results in this program, in this demonstration, is not a member, but a friend to the class performance. So we have our preprocessor directive, IOStream, using namespace standard. Then our class is performance. This class has a data member called subject is called one data member. This data member is private. Then from there, we have the friend function. We have our friend function called results that is receiving the parameter. That is receiving the parameter for the address of the class called performance. So in other words, the parameter that is being received by the friend function called results is the address of the class called performance. In other words, we are granting this function the rights to manipulate the data members of the class in which it is a friend. So this function called results is not expected to return any value to the caller, and it is a friend to the class called performance. The second method is getScore. This is a method that is not expected to receive any parameter and is not expected to return any value. So that's the end of that definition for the class performance. Now, we move on and define the function called results. Just as I've said, you can see that results is a friend for the class called performance. Now, outside of that class, we define the function called results. And you can see it is not preceded by the reserved word friend, and it has no scope resolution operator because this is a standalone function within our program. But it has been made a friend. So anytime you have a function within your program and you want to make it a friend in a class, you just call your function as usual, and then you make it a class. You prototype. You're not making it a class, but you make it a friend a class by prototyping it and that class in which you want it to be a friend. So this function called results is receiving a parameter, for manipulating the class called the performance. And what is the parameter? It is the object or the instance of the class called performance, which is performance object. And what is being received is the address. So this is a pointer. So the parameter we are having in this function called results is a pointer, to the class called performance. So it is the address for the instance or the object for manipulating the members of the class called performance. And that object is called performance object. So this function is a friend non-member function, the class we have already looked at. What does this function do? This function has two local variables or two members. one called result, the other called total, and they are of type result. Then what do we do next? What we do next is we are assigning private value called subject score to result from class performance. And you can see we are incrementing the value in the member called subject score. And how is this possible? This statement is invoking subject score, incrementing that value. And how is that possible? It is possible through the object called performance object. And once that is done, the results are assigned in the local member of the function called results by the name result. So the results attained after incrementing subject score are stored in the member or the memory location called result. And what happens next? What happens next is 100 is added to the current content of the member called result or variable called result. And the overall cumulative results gotten are assigned into the memory location called total. So the next statement to be invoked is to write out the sequence of characters as follows. The score accessed from the class performance is, the compiler will pick the value in the member or in the variable called result, write it out on the screen, and compiler will drop one line. And then it will display the next statement. It will say, or it will pick the current content of the member or memory location called result. It will pick that value, write it out on the screen, followed by the series of characters, and then to 100 becomes, then it will pick the content of the memory location called total, write it down, and drop down the cursor one line. So that's what this function is going to be doing. So this function is simply receiving a value, then after receiving that value and incrementing it, it is assigning that value memory location called results. And then whatever has been assigned memory location result is added 100 to 8. And the overall results are assigned to the memory location called total. And then the function displays the following statements on the screen. The score accessed from the class performance is whatever had been gotten, and what had been gotten, if it is added to 100, becomes a certain value. So that's what that function will do. Then we go to the main program. So in the main program, we are declaring an instance of the class called performance by the name performance object. And then through performance object, we are invoking the function called getScore. So once this statement is invoked, the compiler will go to the class whose object is performance object. And which class is that? Which class is that? It is the class performance. So to come here and invoke the function getScore. So after that is invoked, the compiler will move on, do all what that pertains to, and report back to the caller. And then the main program is invoking the next method. The next method is called results. And what is being passed to results is the object called performance. That is, you are passing over as an argument to the function called results, the object performance object. In other words, you are granting the function called results the right to access the private data members of the class that is being manipulated by the object called performance object. And what is the name of that class? The name of that class is performance. So once this statement is invoked, the compiler will go to the function. First of all, remember it has been told that the function is a friend to class. So that's why it is able to access the members of this class. After all, the performance object for manipulating the members of this class have already been passed over to the function called results. So this function is receiving that object and also receiving the memory address of the object, meaning it's receiving the memory address of the class performance. Then once that is done, it will perform all the activities here, do all that, display those results, and then come back to the main caller and find out that that's the end of main. So where is this function? Remember, we had invoked the function called getScore. We had invoked the function getScore here. So what happened is after invoking this function getScore through performance object, remember, performance object is for manipulating the class called performance. So getResults has been prototyped here as a member of the class called performance. So once the compiler comes and encounters this prototype, it will go and look for the definition of that class outside of the class. And where is this outside? In my case, I have defined it after the main. So this is our function called getScore. And you can see this function has been declared, or the header for this function contains, or the function definition indicates that getScore is a member of the class called performance. That's why we are using the preprocessor, the scope. We are using the scope resolution operators. So the scope resolution operator between performance and getScore is simply to tell the compiler that getScore is a function that has been declared within the class called performance. This function is not receiving any parameter, and because it is void, it means that it's not expected to return any value to the calling program, that is, to the calling function, which is main. Once it receives, or once you have the heading for that function, the next is to define it. What's supposed to do? It is provoking, or it is prompting the user to enter a score to the class. And then the user enters a value, and that value is stored into the subject's score. So meaning, because getScore is a member of the class called performance, the value that is going to be entered there will be assigned or stored in this member called subject score. So that's what this function is doing. It is prompting the user to enter the value, and the value is entered and assigned into the member called subject score. This member is a member of the class called performance. And because getScore is a function, is a method, is a member of the class called performance, then the function is able to access the data members of the class in which it is a member directly. And then once that is done, that's all. That's the end of that function. So once that is done, our program will have completed its responsibility. So the following is a demonstration on how this program is compiled and executed in C++, and the kind of output that it will generate. So let's start our C++ program and code this program. So just as I've always said, my dear students and the rest of the learners, copy this program. Copy this program into your exercise book or into a 1D processor. And then once you have copied it, you can also, by then you can also copy it in your exercise book and then dry run it in your exercise book. So once you have copied this program, you have checked and confirmed that the syntax is okay and everything is okay, then you launch your C++ program. So let me launch my C++ program. So I'll launch my C++ program, my C++ program, as you can see. What is important to ensure that you make your editor to be ready for coding, depending with the version of C++ you are using. Now, I want to give my project a name, and this name will be friend. It will be friend functions. Friend functions, because I want to indicate how friends functions work. Always give your programs meaningful names, names that you can remember what they were used for. Then we want to write a source file. We want to write a source file. So this source file, I will still call it friend functions. And then I'll click on add. So our editor is ready. Once our editor is ready, then you can type your program or just copy it and paste it there. If you have coded it in a 1D processor, like on my case, I have already coded my program here. So I will copy this program and then I'm going to paste it on my C++ editor. And once you paste your program here, once you paste your program, you can save it. Remember, if you have written it in your exercise book, just type one line after the other. Type your code into C++ editor. Once you are done with typing, click on save. And then proceed and compile your program. Compile your program using the methods that I've already discussed before in object-oriented programming series, as well as in the C++ computer programming series. You can see that our compilation is successful, meaning our program has no errors. So we can execute our program. So let me execute my program so that we see the results it will give. Now, our output reads as follows: enter a score to the class. Which function is doing this? Which function is this? The function, if you look at our program, the function is get score. This function here, this function, get score, which is a member of the class called what? Called performance. So let's enter a value. I'll enter 78. I'll press enter. You can see that already after entering the value 78 through the function called getScore, because this function is a member of the class performance, as you can see, the value we have entered and see in a subject score, that value has been stored or assigned to this member of the class called performance. Then after doing that, Then after doing that, you can see the next statement that will be displayed on our screen is the score accessed from the class performance is 78. This statement is this one here. And which function is displaying the results? It is the function called results, which is purely a friend of the class called performance. So how is it able to get the value that has been entered through the function called getScore? It is because it is a friend of this class called performance. And as a result, you can see from the main that we assigned or we passed over the object for manipulating the class called performance as a parameter. We passed it over as a parameter to the function called results, and this function is a friend. So we were able to pass the object for manipulate the class called performance because this function is a friend to the class called performance. So in that case, it means that the function called results is then able to access the value stored in subject score. So that value has been received. Once that value has been received as a parameter, once that value has been received, once that value has been received, you can see what this statement was doing is to assign private value called subject score to results of the class performance. So that value, the value which has been received, is assigned to the member called result. So we have entered 78. That 78 has been assigned to the member called result, the variable called result. So 78 has been stored there. And then you can see next statement is to take what is in the memory location called result and add 100 to 8. We have entered 78. So it is 78 plus 100. That gives 178. That 178 is stored in the member called total. And then we are writing out the statement. The score accessed from the class performance is, so what is in the memory location called result? It is 78. But what is in the memory called total? So what has happened is the score accessed from the class performance is, we have entered 78. So at 78. So it will display 78, then move one line below. And then next statement is to pick the value in the memory location called result. And what is the value in the memory location called result? 78. So 78 will be displayed on the screen, followed by the ones, and then to 100 becomes, it will then pick what is the memory location called total. And what is there? It is 78 plus 100, that is 178. So 178 will be displayed. And that's is the end of that function. And you can see that the score accessed from the class performance is 78, 78 and then 200 becomes 178. That's the end of that program. Let's compile it, let's execute it again and a different value. So if I enter, for example, 789, you can see the score accessed from the class performance is 789. That's what we have entered. 789 and then 200 becomes 889. So my dear students and the rest of the learners, that's how friend functions work. That's how friend functions work. So after having coded that program, it's also important to note that a friend of a class performance is a function or a class that is not a member of class performance, but is granted the same access rights to performance as the members of performance class. In other words, we are saying that if you make a class to be a friend of another class, or you make a function to be a friend, I repeat, if you make a class to be a friend of another class, or you make a function to be a friend of a certain class, then what you are simply doing is that you are granting that class which is a friend or that function which is a friend access rights to the class in which it is a friend. As you have seen, our friend function has been able to get the rights to access the members of the class called performance. So functions declared with a friend specifier in a class member list are called friend functions of that class, such as the function called results in the example I've already demonstrated. However, a class must be defined first before any member of that class can be declared a friend of another class. For example, a class called unit scores must be defined before any of its members, such as print, can be declared a friend of another class, like the class called performance. So in the following example, the friend function called print is a member of a class called unit scores and accesses the private data members score 1 and score 2 of class performance, which have been assigned values 45 and 62 respectively. So the output displayed from this program is similar to the one which we have gotten or which we got in my other presentation. That is from the previous part of this series, where we saw the program was writing out the score is 45, that is score 1 is 45, and score 2 is 62. Which program am I talking about? I'm talking about the tutorial that was dealing with friend classes. That is presentation number 27 of the series. So for you to remember what a friend class is and how it works, kindly go to MLSWAP ICT YouTube channel, of course, from where you are listening this video from. And then look for part 27 of the series, and you'll be able to understand the difference between the class function or what we call the friend class and what we are discussing in this presentation about friend functions. So we have friend class and friend function. Part 27 talked about friend classes. Here, we are talking about friend function. So our program is by the name friend of class. Of course, we have a preprocessor directive there. We have the using namespace. Now, here, we have our class as usual for the performance. Here, we are prototyped. We are prototyped the performance class before it is used. Where are we prototyping? Before, we are prototyping so that we can be able to refer to this class within our other class called unit scores. So we have prototyped the class performance so that we define it later. And then we now declare the class called unit scores. Now this class has private member or public, not private member, but public member. This public member is a method. This method is called print. It is receiving a parameter called performance, the address of the class, address of the class, address of the class in which performance is an object. In other words, this function called print is receiving a pointer, to the class called performance. And that's all with the definition of that class called unit scores. Then from there, we now define the class called performance that we have just prototyped. Why have we prototyped before using? Is because we could not refer to anything that concerns it or any member under the class called unit scores before we have made the compiler be aware that such a class exists. So we then define the class. So the definition of our class performance is as follows. It has two private members, score1, score2 of type integer. Then it has a friend function. There's a friend function. Note this friend function is print. This friend function is print. Print is a friend. We are making print a friend of the class called performance. So the print function that is receiving a parameter, which is a pointer or which is an address of the class called performance, is, I repeat, here at the class called performance, we are prototyping a function. That function is called print. It belongs to the class called unit scores. And this function is receiving a single parameter. And that parameter is the address of the class called performance. Note, this is a friend function. It is a friend function. So the function called print, whose scope is unit scores class, is being made a friend to the class called performance, so that it is then able to access score1 and score2. Then we have a public members. And what is under the public? So under the public, we have score1 being assigned, or 45 is being assigned to the member called score1, while 62 is being assigned to the member called score2. That's what this function is doing. And then that's the end of the definition. That's the end of the definition of the class called performance. So we then now define the function that you have just prototyped. We define it outside here. So we define the function called print, which is a member of the class called unit scores. That's what the scope resolution operator indicates. So this function called print, whose scope is unit scores, is not expected to return any value. The invoking program or invoking function, but it is receiving one parameter, just as I've said. So it is writing out the statements. Score1 is, it is picking the value in the member called score1 through the object that has been received. And that object is what? The object is performance. Then it is writing out the next statement. Score2 is picking or reading the value in the member called score2 and writing it out on the screen. How is it able to access score2? It is through the object called performance. And note, performance has been passed to the function called print as an object. And that's all with that function. So the main function is doing the following. For one, we are declaring an object to manipulate the members of the class called performance. And that object is called performance object. And then we are declaring the second, we are declaring the second object to manipulate the class called unit scores. And that object or instance is called unit scores object. Once we have done that, we are passing the object called performance object to the function called print through the object for manipulating the class called unit scores. So once this is invoked, the function called print will be executed. And what is that function called print doing? It will display the value for score 1 and the value for score 2 that it is going to access from the class called performance. And that will be the end of that program. The control will be taken back to the operating system and the program will end. So the following is a demonstration on how this program is compiled and executed in C++ and the kind of output that it will generate. So my dear students and the rest of the learners, as usual, copy this program either to editor or to your one processor, copy it in your exercise book. Once you have confirmed vis-a-vis my program that your code is okay and the logic and the syntax is okay, you can then code it in C++ editor, or you can just copy and paste it. So let's proceed. Let me start my C++ program. So there we go. You can also start your version the way you do in your computer. Then I'll click on File, New. I want to start a new project. This project, I'll call it the name, friend of class. This is to avoid repeating friend functions. Then I will start a new file. The new file for my source code will be called friend of class. Remember, we are talking about friend functions. You can then now type your program under the C++ editor. But if you have it in Word, if you haven't typed yours in Word like me, you just copy it and paste. So if you have yours, for example, you have coded it using a word processor, like for my case, you just need to copy that program. Just copy your program, like the way I'm doing here. Just copy your program that you have already written in or using word processor. Go back to your C++ program and paste it there. If it is in your exercise book, just look at your exercise book and then code each line in the C++ editor. Ensure you indent your program or your code nicely for ease of reading or to make reading easy, so that you can be able to know what is where. And in the case of an error, it can become easy to identify where your problem is. That's the importance of making your program readable. And one aspect of making your program readable is through indentation. So like this is now a readable program. You can see here is my program. So once you are done with the coding, just click on Save. Once you click on Save, of course, you can then compile your program. Compile using the procedure that you use. Of course, like in my case, we are clicking on build, then build solution. There are other versions where you click on build, then compile, or just build. So the important thing for you to note is that after you have written your source code, you compile. What is to compile? To compile is to convert your source code into an object code that is machine readable. So you can see that my program has been successful. Compilation is successful, and therefore our program, our source code has been compiled to object code. Let's now execute it, because that one can be understood by the compiler or the CPU. So you can see that after we have executed our program, it is displaying an output. As you can see, it is displaying the output as score 1 is 45, score 2 is 62. Remember, these values have already been predefined in our program. Or in other words, they have been pre-assigned. Which part is pre-assigning the values? Is this part here. You can see score 1 has been assigned value 45, and the score 2 has been assigned value 62 by the function called performance. And therefore, when we come to writing out, you can see because unit scores, because the function called print is a friend of the class called performance, then this function is able to access the data members, the class called performance. And therefore, the value in score 1 is rent, and therefore the statement cout score 1 is. The function or the compiler goes to score 1, picks the value which is there, and writes it out on the screen. And the value which is currently there is 45. Why? Because 45 has been pre-assigned within the code. And then it moves on and goes to the member code score 2, picks the value there, and also displays it out as follows. Score 2 is 62. 62 is what is currently in the variable or in the member, in the data member called score 2 and the class performance. And that's all. That's what the program is doing. So you press Enter key to continue. We save our work. And once you are through with saving your work, you usually click on the close solution. You click on close solution. And then now we can proceed to the next part of the series. So congratulations, because you have now been able to learn about friend functions. So you can continue to part 29 of 95 of the series, in which we are going to learn about what we call the static class members. Of course, this also includes the handling of objects. So static class members and the implementation of objects and classes topic. So congratulations. Congratulations for learning part 28 of 95 on friend functions and implementation of objects and classes in object-oriented programming. You can access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on the MLSAP ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video in YouTube if it's not currently reading as subscribed. Remember, you can also join MLSAP ICT as a special member by clicking on the join button in this channel or for the channel. For any further correspondence, kindly write to us through the email mlswap@gmail.com. Thank you very much for listening to me. Let's meet in part 29 of this series, and God bless.